Hi, I'm Jim Wilson. I want to welcome you to the AgTech YouTube channel. We're going to go over Keep the Current Flowing. We're going to be going through a program, how to test 12-volt batteries, and let's get started on the program. Okay, our class is Keep the Current Flowing. We're going to do some low voltage battery trends and service updates. Things are changing in the field. So some of the things we're going to be looking at is the knowledge of the type of batteries are out there. We look at the testing procedures. They're changing up there. When we started coming out with different batteries for different systems, for stop and go, so there's a lot of things to talk about as we go through with this class. Okay, when we're looking at our tool set we've been doing for batteries before, we mainly have been doing a VAT40, which is a good tool to use. That's a generic term for the carbon pile tester. But as we go forward, and we're using your digital voltometer. Now the digital voltometer is now called a DMM, digital multimeter. Same thing that we're going to be still going to be using that tool. But the big thing about it is you're going to have some kind of electrical system analyzer. That means you're going to be able to test the charging system and the battery on the vehicle all with one component. Because as we go through, you have to be able to test differently on different types of batteries, which we'll get into a little later. The other thing is you're going to have to swap out the old charger that you had for years. You want to go to what I would call a little bit of a maturing or new type of electrical charger. It is sophisticated and smart. It will actually set the thing up for the particular battery you're using, like an AGM or a sealed lead acid battery. That makes it a little bit better. It also will sit down and actually tell you when it's done charging, which is kind of a neat little tool. You also can use it for your J2534 as a device of keeping the battery up when you're doing a reflash. Your scan tool. Most of us have never really used the scan tool too much for checking for the charging system except the voltage. Nowadays you can actually you can change the alternator output, you can do other component tests with the system, and you need to be able to use your scan tool. The other thing is on some of these newer batteries and the ability to look at the charging rate, you're going to have your scan tool there to do the diagnostics. Plus, when you replace the battery, on a lot of the batteries now have the battery sensors on them for charge, you're going to have the ability to actually tell the computer in the car that you have put a new battery in. If you don't do that, it's going to remember the old charge rate and it's going to destroy that new battery you put in, because over a period of time the charge rate increases and the amperage increases. So that's something else you need to look at. There are times you're going to need a lab scope. You're going to look at a lab scope for signals from your alternator, or you're going to be looking for signals being on the network as it's being going across. So some of these systems are being charged and they're on the network, so they have to have ability to look at if you have a network issue. And the last thing we always have to have is an inductive ammeter. It's a good idea if you're doing battery and alternator testing, you're going to have a low amp probe and you have to have an IAMP probe. So these are tools that you have. So again, you're going to have to increase your tools that you use to diagnose these new batteries that are showing up in the field. Okay, the battery construction basics, if we're looking at, we have positive and negative plates. We have some separator plates. There's a case, which a long time ago they were made out of rubber, and we had places, we had balsa wood separating it. That's a long time ago. We also have plate straps in there, electrolyte and terminals. Now your positive, negative plates and separator plates, the positive plates, I want to make sure you understand, are reddish brown lead dioxide. Negative plates are gray sponge lead. Now the other thing is, if you're looking at your battery, there's a grid up there that's there, and they can be made of antimony or calcium. The biggest thing about it is the lead stuff, when you're doing the plates going vertical, we have a little bit of a problem with that. So by adding the antimony or the calcium, it strengthens that. The calcium is usually used in what used to be AC Delco's maintenance-free batteries, and that was there. It strengthens, has a little ability to help out. Each cell has 2.1 volts, so we add 6 of them. We add them together, we got 12.6 volts in the battery. Our electrolyte that we have is 30% acid, sulfuric acid, and 64% distilled water. And a lot of us older people that are listening up, they'll remember adding water to the batteries. Most of the batteries we have now are sealed lead acid batteries. You're not going to be able to do that. And the normal terminology is maintenance free. Now, if I go to my next slide, we'll look at some battery constructions going up there. That grid I was talking about, if you go to the lower left-hand side of your slide there, you will see that's the grid that the antimony or the calcium is made up of, and the point to strengthen it to get it up. And if we're looking at different components in the particular battery, some of the batteries now have, older ones had a little plate at the top where you could remove it, add the water. That's long gone. But we're looking at just the battery construction of it, and it's just a reference. You need to let your students know this, your techs know this. There are things up there. Sometimes the battery under vibration will cause an issue, and we'll have a breakage as the connection straps are in the plates themselves. So it's kind of like an overview of what the battery construction basics are. Let's go on to the next thing. We're going to do some battery ratings here and specifications. You have to make sure you have the right battery for the vehicle you're looking at or you're working on. So the co-cranking amps is a rating we normally see. We'll talk about that in a second. There's cranking amps, amp hour rating, reserve capacity. Then we have to know the battery size, and we're going to look at some battery hold downs to make sure you understand you need to tighten those down correctly. And we're looking at date of manufacture. So if we're looking at some of the systems that we're looking at, first of all, co-cranking amps is the one most of us are always using. And this is a rating of the batteries to provide a certain current level. If you look at it, a fully charged battery can supply for 30 seconds at 0 degrees Fahrenheit without having a battery temperature voltage drop below 7.2. So in other words, they're going to put a battery in the situation at 0 degrees, and they're going to check the voltage, and they're going to make sure it does the job. That's some of the things we're looking at. So a lot of times, this is something you want to make sure you match whatever the specifications are for your vehicle. The other thing that came up is another specification. It's called the co-cranking amps. Indicates an amps at a fully charged battery can maintain it 32 degrees. Now keep this in mind, 32 degrees while maintaining the 7.2 volts or 1.2 volts per cell. Now, the CA ratings can be misleading because they are always going to be 30% higher than you would have with a CCA rating. So keep this in mind. Again, at 32 degrees versus 0 degrees, there's a lot of difference. So the Battery Council requires that you must have both ratings on the battery. If you have a CA rating, you must have a CCA rating on the battery. So those are some things they're looking at it. And there is a council that goes over and looks at and rates batteries, tells you how you're going to set things up if you want to look at some more information there. Now, if we go over to the CCA rating and the CA rating are both on this particular screen. If you look at it in the yellow, it's 890. If you look at the one in the red, it's 725. So that is a CA rating and the CCA rating. You really want to always use CCA rating for getting the battery for your vehicle. Just something to keep in mind. Notice the manufacturer had to put both ratings on this particular battery. If I go to the amp hour, which is what we used a lot of times in the past, is another important design or important setup of the performance of the battery. Amp hour is expressed as discharge rate or discharge current of a fully charged battery that can deliver for 20 hours at 80 degrees Fahrenheit while maintaining 1.75 volts per cell. So we'll look at it 10.5 volts. There's another rating we have on this one. Now the amp hour rating is also a good idea to learn to use it in order to how long you're going to charge your battery later on if you have the amp hour rating. We'll get into that a little bit later. The last one is reserve capacity. The time in minutes, how long a fully charged battery can deliver 25 amps at a current temperature of 80 degrees Fahrenheit before being discharged down to 10.5 volts. So those are reserve capacity to look at. So those are the ratings on the battery. Most of us are always going to use co-cranking amps or CCA. But the other ratings are there on some of the batteries. Some of the accessory batteries you might buy for your boat or for other processes or other things you might be using, you would use maybe a different rating. Now, if we go up here, battery group size. They're going to want to know what size. The BCI also came up with this one. So it's going to have to know the height, the length, and the width of the battery. Each battery compartment for the vehicle has a certain designation size that's there. You cannot stuff a bigger battery into the same spot. So what they want you to do is make sure you get the group size. Now the group size in the battery is going to vary. On this particular battery, my group size is 24F. So there is a chart for the battery. This is the one that you're looking at. And by the way, just curiosity, always take off the little red and black caps before you put the battery cables on the system. We just had a guy call me up with a problem. He couldn't get the car to start, and the problem was that he put the cap over the black one, tried to get it to run. So something to keep in mind. If I go to my next slide, it looks at date of manufacture. Now, there's something else to look at. Some of the newer battery testers out there will read the bar graph. Now, if you look it up, there's a bar graph underneath the handle. You'll see it on the right-hand side across from where the red terminal is. It will actually give you the bar graph up there, tell you manufacture of the battery, the date is manufactured also, and tell you the correct cold cranking amps of that battery in your testing. So your little tester will actually read that and set up its charge rate, its testing rate for that particular battery. And it will do a really good job of giving you information up there. You can actually, on some of these new little testers and the analyzers for the charging system, build up a database of the vehicles you have tested across the board and gives you a reference that you can use at a later date. Now, if I'm looking at battery hold downs, most of us always crank that thing down as tight as we can, and that's not the way to do this. So a lot of times we're looking at it, you want to tighten it, reinstall the battery and hold down. This is the one on the side. If you do not install the battery hold downs correctly, you can crack the battery. The other problem is a lot of the manufacturers now are coming out with little bulletins about the batteries coming loose in the particular vehicle. One time I worked on an Opel, and that's a long time ago, where the battery hold down would not even correctly hold the battery in place. If you did any quick movements, the battery would actually bump in there and nobody could find the noise because the battery was loose. Prevent damage to the battery from movement, possible shorts to connectors. It's something you look at because the battery move, it could actually short and cause a problem. Now, this particular setup here, we're doing some battery hold downs you're going to see there. And our torque for that, I just did what was it? I did an Equus, I think, the other day, and I was looking at torque just for something that we can add. It was 17 foot-pounds to hold it down. So some of us are probably cranking it down a lot harder than that, and we can cause damage. If there is a spec, use it for torque, all right? Just do it because it saves you some time, and you're also going to make sure the battery doesn't fly around under the engine compartment. Okay, when we're looking at battery terminal posts, the battery positive post is always slightly wider than the negative post. And you notice I have a plus there. You'll also see some batteries marked with a POS, which is positive, or NEG for negative. And you want to look at the particular batteries and make sure you're hooking up correctly. I have seen sometimes where guys are not paying attention and they have hooked up at reverse, which will cause damage to the system. So always be careful you hook up the right side. Also keep this in mind, if you're disconnecting the battery, you always disconnect the battery, the negative post first, and then you do the positive if you're going to remove the battery. Something keep in mind when you're doing processing. The other thing we're looking at is battery terminal clamps. Now they've been changing over the years. We used to have the lead clamp with the cable that you would actually put in, and that was a long time ago that we had those. But the one on the steel, you see how it used to be connected directly into the terminal. So now we have lead and we have steel terminals. And by the way, the steel terminals on a lot of batteries can be replaced on the Chrysler, I know, because I just replaced mine recently. The other thing to keep in mind, if you're torquing these things down, make sure you do a proper job of it. There is a good idea that if you're taking the clamps, you always clean the battery terminals and clean the clamp itself or the terminal there, making sure they're clean. Get your battery terminal cleaner. The other thing is some of us have some chemicals that we can spray on there. Used to be other ways of doing it. Make sure the batteries are nice and clean and bright before you put them down, the terminals down on there. The other thing I would suggest, some of us old school guys used to use a little red and black pieces underneath, you know, the little piece of cloth, the circular rings around there. I still do that. The other thing is you might want to spray some kind of protective coating on it after you have serviced that system. that makes it a little bit easier to use. So make sure you're putting it back. Now, the one thing I want to make sure everybody does and keeps this in mind, there are times you're going to have that universal clamp where you're putting it down with the 2 bolts holding it down, the one a lot of your younger people will do because they don't want to buy a battery cable. There are times those replacement terminals are there, and you want to make sure that you get rid of those as soon as you can and put the right battery cable there, or you make a new battery cable in that will be used. It is not a good idea to use those universal up there. There's been so many times when I used to work for the Auto Club in Missouri where I would actually have to tighten the clamp down and get the vehicle to start. I would tell them to replace the cables, and that's something you should do. I've actually seen times where the cables are so bad that guys put the universals on there and it makes it even worse. So make sure that you are replacing the cables as part of the service with the correct one for the vehicle. Okay, when you're looking at your flooded battery, you always want to check the open circuit voltage. You're going to use your DMM to do that. Now, if you look at the process, we have a state of charge. That is SOC. You're going to start seeing that with your scan tool, and some of the newer cars are going to give you that as information. If you look at this particular battery, I have 12 volts on it. 12 volts actually equals 25% charge. So this battery has to be recharged, and this is why I showed this up here, because I have a car out there that was giving me a little problem, and I charged it back up. But there's something we need to understand. There is a surface charge. If you have a surface charge on a battery, it'll be above 12.6. So if you were testing a battery, you would want to remove the surface charge by putting your headlights on for maybe 10, 15 seconds, 20 seconds to pull the surface charge off. So you start with a 12.6. Most of the time, a lot of techs just don't do that, just go ahead and test. So the next thing we want to look at, there are some changes here. So we have a state of charge at 100%, an AGM, sorbent glass matte battery, which we're going to be talking about, will be at 12.8 to 13 volts. That's not a surface charge on that one. That is what the open circuit voltage will be. So you're looking at a little bit different reading. If you look at conventionals, 12.6 plus, all right? If you look at, let's go down to the one at 50 to 75%. It will be on AGM, it will be 12 to 12.5, and you're looking at 12.1 to 12.4 on a conventional battery. So you want to make sure you're looking at open circuit voltage to diagnose the system and to see the state of charge with your voltmeter. Make sure you do it accurately for the type of battery that you have. All right, if you're going to test a battery, there are times you're going to have a little bit more time to do it. First of all, we got our little battery cover. Some people call it a heater, some a protection, whatever, shield or whatever. On this particular one, to get my access to the battery itself for the identification, I had to remove this. Now, most of the newer batteries have a bar graph, which is on the very top of this particular battery. So some of the chart testers that are out there would just look at the bar graph. If you look at what I've got here, I've got this tester hooked up. I'm at the black and red cable, and I'm hooked up to look at my test. Now, if I go over to my screen over here, I've got a battery test, a cranking test, a charging test, and it has a system test. So I can do a complete system test on this particular vehicle. Something's kind of unique on these. A lot of the new ones have a battery library, which means that they have these specs based off of the car that you're hooked up to. Or they have a spec where you just read the bar graph, it automatically knows what it is and puts you general information that you need for that particular battery. We have a test report, and we have a user guide, and we have the settings. That's what's on the particular setup. So these things are going to be a little bit better than we've had before. First of all, we're just going to do a battery test. Click on the battery test, and it says it's an AGM. I had to set it up for an AGM. It's a flat plate. It's not a spiral. I set it up for co-cranking amps, and I set it up for 760 amps that we look at it, and it says that. I hit next, and you will see a little bit of time, and then it will display on the screen what it thinks is going on. So first of all, it comes up here. Now let's still talk about this a little bit. It says battery type, AGM flat plate, co-cranking amp specs. It does my battery value, 760. it tells me that the state of health on this battery is 100%. It tells me a state of charge is at 100%. And it tells me my test value was 838 co-cranking amps. So I'm above the rating on this particular battery. And it also gives me my voltage, 12.69, 100%, it's always 12.6. And it gives me internal resistance. So they were actually going out and internally checking the resistance on this battery and giving you a report of what's going on. Now, I could print this off, I could share it, but if you're looking at all the information there, that's really good information. It does a really good job for giving you what the battery is doing. Now, if I hit this one button back out, I have also, let's go up here, I'll do a test report. And these are the 4 batteries we have tested today. And they're almost the same one on a different car, but it gives you the test report, and you can select all, and you can delete them if you want to, you can keep them. But the advantage of this is you have a database on some of the cars that you're working on. So if you've worked on and tested the battery and 2 weeks later they come in and the battery's got a problem, you know it wasn't the battery necessarily, it was something else affecting the system. You also have a user guide. So if I have a user guide, it would come up and tell me what my next step and how to use the tool. So that's real quick things you can do with one of these battery tester analyzers and do a really good job and give you a database. The advantage of this is it has a database that you can use as reference. It also has the ability to allow you to save information. And the big idea is that, let's say you are stocking batteries in your shop. If you stock batteries up here, I can give a running test and see how good the batteries are, whether I need to recharge them before, as they're sitting in storage for the next vehicle that might need that particular battery. A lot of good information, great tool to have. This one's from Topdon. I'm sure there's some other ones, but this one works really great for what we're doing. All right, we've moved over to the 650D engine performance testing, which is the diesel. It's the 250. And it's a diesel. We've disconnected the battery on the other side because you only should really test one battery at a time on the system. We get some faulty readings if you do. First thing I'm going to do is I've hooked up to the battery. I'm going to hit battery test. And I need to set it up for the vehicle I'm working on. So the first thing I want to do is hit for regular flooded. And at that point, it asks me, do I want to do co-cranking amps, BCI, CA, DIN, or N? So we're going to go CCA. And I'm looking at the battery here. It's a 750, so I hit battery values and 750. All right, and hit click. Now, at this point, I'm set up for the vehicle I'm working at. I'm going to hit next. As we go through here, it's going to spin and do a job for us. And if you look at it, first thing it came up with is a bad test. It says, please retest after charging. Now, what it did says is regular flooded, our state of charge is 30%. Battery standards is CCA, it says battery value 750. And if you look at state of health, is at 30%. So we're looking at a vehicle as discharged. So in order to do further testing, but I wanted you to see the battery voltage is 12.1. 12.1 volts indicates the battery is pretty well down. There are some technicians or some people I know will tell you, well, it's a 12-volt battery, that's okay. No, it must be 12.6. As we covered before, if I'm under 12.6, the battery is going to be decreasing in strength and health, so we have a problem. So right now we got to know we got a battery test problem on this one. We're going to charge and retest. We can use a formula up there or a smart charger and chart these thing up and get it up to capacity. So there's our test with one we have failed. The other thing is if I hit back out here and I do a test report, notice it gives me the test report of the battery that I did. Test value was 408 co-cranking amps. So we know his battery is not up to par. We also know the resistance is a little bit different. And we also notice that looking at the battery is 12.18, 12.2424. But the process, we need to make sure that you're looking at the voltage properly and recharge the batteries when necessary. Now, while we're here, we're going to be some other stuff on drivability and some stuff on computer systems. Everything is relying on that battery or these batteries being in good shape. If one of the batteries is down, it will affect all the systems in the rest of the vehicle. So get used to checking the battery and the systems and the charging system on the car before you start doing any diagnosis. You need to do that as we have networks that are relying on good absolute voltage and everything else on the vehicle. This is something we need to do on a regular basis, and since we have the analyzer to do it, It doesn't take that long to do it, guys. It's something we need to do. Okay, there's different types of batteries you're going to be seeing. It's not the same old stuff that we do with your father's Oldsmobile. Maintenance-free batteries, we're pretty familiar with those. There's a new thing called an enhanced flooded battery. I just installed one in my daughter's car just recently. Recombination batteries, we'll be talking about those. There's two particular batteries that have that. There's a gel cell battery, which a lot of the performance guys use to go around and do the process, because it doesn't leak in a particular car. You can mount it on your sides, you can mount it any way you want to mount it. We also have the sorbent glass mat batteries. Those are the new batteries being installed in most of the start and stop vehicles and other vehicles because they are a little bit better. We also have valve regulated batteries, which goes back in with the recombinant battery, combination battery, and then there are lithium batteries. So these are batteries you're going to see in the vehicles. These are just the standard. This is not the hybrid we're talking about. But there's a 12-volt battery in a hybrid. Of course, that's changing. The last I heard, they're going to go up to maybe a 20-volt battery. So maintenance-free battery, still known as a sealed lead acid battery. They don't have removable caps or vents like we used to do when I was first working on cars, where we would add water over a period of time. The cases are sealed and they have pressure relief valve insides. The sealed case, if you look at it, prevents water loss due to heat and charging like conventional batteries. The pressure release valve inside regulates the internal pressure of the battery, and it opens to release pressure but maintain the water in the battery. That's what a maintenance-free battery is supposed to do. Now keep this in mind, that if you were ever charging one of these, if you overcharge it, it will pop those pressure relief valves, and now the battery will tend to go bad very quickly after that. If we look at an enhanced flooded battery, the one thing you want to look at is the grid that we have up here. You have a very narrow grid where it's actually a lot more surface area. There's a lot more lead in that particular grid. Now, the biggest advantage of these are more durability. They have more energy storage. I just recently did one where I checked the battery out and it was rated at 600 co-cranking amps. The car would need 590. When I checked it with my battery analyzer up there, it said it was 680 co-cranking amps, so it's a little bit stronger. These are weatherproof. They're start-stop friendly. That's what you're going to start seeing. We're going to have dual batteries on start-stop on some of the vehicles, and these things have more lead plate material. And what there's going to do is they're less costly than an AGM. That's your enhanced flooded batteries. A lot of people are starting to use these if they can as their standard battery. It works really well. Then if you look at it up here, you're looking at the plate, looking at the separators. Each thing is a little different way of doing it thing. So we have little separator cells in there, and we have the plates encapsulated in some points to prevent flooding and moving around. The biggest thing I'm going to look at is the grid itself. There's a lot more surface area, so we have a lot more energy out of this particular battery. Again, you're going to start seeing these in start-stop vehicles a lot. Valve-regulated batteries are out there. The gel cell and AGM batteries are valve-regulated, which means they recombine the hydrogen and the oxygen created during charge and discharge, and they bring that back into water, and they flow that back into the battery. It keeps the water levels within approximate limits. It keeps them in the process. It keeps from losing water, and it does a good job of keeping the battery at a constant level. The other thing is the battery must be fully charged to a particular voltage level. You cannot overcharge these. So if you went above 15 volts, like some of your battery chargers, that little battery charger I showed you before will go up to 17 volts when it's charging a battery. If you go too high, it will actually damage these style batteries. It will pop that little pressure sensor in the VRL, and it will cause a problem, and you will discharge and the water will go out, and you'll have a bad battery over a period of time. So you want to actually, if you're doing this one, you want to make sure you charge it at 12 volts. If it's a valve-regulated AGM, you must tell the system it is an AGM battery, and it must be done to prevent damage to the particular battery. Something a lot of us don't think about, but now all of a sudden, that's why I have to have a different battery charger. I would definitely not use my old battery charger on these particular vehicles with this battery. The other thing, if you look at the top of this was from a friend of mine at Associated, and we had a little confrontation it was when we first started about on batteries. And we went back and we talked about it for a period of time. I just wanted to put them off guard and to get some information off of them. And when I got up here, if you look at, this is off of the vehicle that you're looking at. This is off of Chrysler. This is that you've been looking at it. And you look at it as do not what? It says do not, I have to pull my glasses out for a second. But if you look at this process, it says do not charge over 14.4 volts. So some of our charging systems that our cars have will charge more than 14.4 volts. So you want to make sure you're looking at the right information. Do you also look at it, this battery, if you look at it at the top, it actually gives you the amp hour and the co-cranky amps. Again, make sure when you look at the battery of the vehicle you're working on or charging, make sure that it has not been, some of the guys are putting AGMs in a normal car. So make sure it's not updated in doing the battery. If I go to a gel cell, again, these are a lot of times you're going to see this in hot rods, you're going to custom cars or whatever, because it can be mounted any way it wants to. It's got a spiral design, which is a little bit better. A spiral design makes it more compact, so it has a lot more energy available from the battery itself. This is a lower resistance. It's always usually in a smaller style case, which means that you make sure that your hold down's working properly with the system. They have a faster recharge rate. And the last thing is they use a silicon dust in here. So they add the silicon dust with the electrolyte in order to hold things in place. These things will not move around, everything's working. So they use a gel in these. So it's silicon dust is added to the electrolyte to do that. If we go over, again, it's talking recombinant batteries. Again, same thing. These batteries are still classified lead acid, but they also have the nomenclature recombinant batteries because of the cells in there and the way the valving in there to keep from losing the water and combine things back together. That's one of the terminology you look at. Now, sorbent glass mat batteries, unlike flooded ones, does not have free-flowing electrolyte. Neither did the gel side. The free-flowing electrolyte and gel cells and the free-flowing electrolyte are not in these particular batteries. They have separators, and they're going to use glass fibers in it. Fiberglass fibers in there, basically. And what they're going to do is they're going to hold the electrolyte in position. And it's partially like a partially saturated, it's a sponge, basically, that they're going to use in the process to hold everything in place. The advantage of this is they're very not affected by vibration. They can be mounted a little bit in better places. They will also can be mounted in a different format or different side, maybe on a side on some particular cars, and most of them are straight up and down. The other one, they're valve regulated, just like I just said. They combine the hydrogen and the oxygen back in with the discharge. For the process work, these guys, again, I'm repeating myself, they must be charged at a specific voltage. And each cell has its own valve. If they're overcharged, the gas pressure will build when the cell rapidly, and if it exceeds 1.5 psi, it will blow the valve up there, open the valve, and let the gas escape. When it does that, now you will dry out the battery like an overcharged flooded battery, so you have an issue. Keep this in mind also when you're watching the temperature. If the temperature gets excessive, you're going to pop these valves open also. So keep this in mind, all batteries, if it gets too hot, you're going to have problems. Some of you, just like me, have smoked a battery a few times where you got the voltage up too high and the temperature increased and you smelled it going across. That happens. The other thing is there are two types of sorbent glass mat batteries, or AGMs. There's a pure lead and there's an alloy batteries. The pure lead is 99.9 pure lead in the system. They have up to 2 times the life of a flooded battery or an SLL battery. They have a faster recharge time, and they can take higher amperage when you recharge them. Can't take the voltage, but they can take the amperage. They have the slowest discharge. And what does that mean? If you take a battery and set it here for a while, over a period of time, it will discharge. They have the slowest discharge rate of all, and they're sealed so there's zero water loss. You have the same process on the alloy AGM batteries, but they're using recycled lead plus an alloy material. It's a little bit different, not pure lead, so they don't have the strength up there. They're not as powerful as a the pure lead AGMs. They're less expensive, but in reality, you're not getting the strength that you need from like an AGM battery. Now, the newest thing that we're going to start seeing is this, the lithium batteries. They're lithium ion batteries. They're lithium iron batteries are starting to be the new process on it. They're an advantage of that. Number one, they're small. They're lighter. Let's say they might be like 13 pounds for a 12-volt battery, or that we normally would see might be 40 for another style battery. They can withstand charge and discharge cycles better than a lead acid battery. The battery ratings are much higher. The disadvantages, keeps in mind, they do not allow charging of that battery at the same rate we normally look at. So there's probably going to be this. It's going to cost up to $1,700. I do have a friend of mine who's a race car. He runs his car on the weekend. He will switch over to a lithium battery to race. Once he gets done with the racing, he flips it back to the normal SLA battery. The reason he does that is the charging rate is different. He'd have to have a process. So what they have is they need a charger converter built into the battery or with the battery to do it, because it has a lower voltage on the battery for the charging. You just can't put these in a normal charging system. Some of the more expensive cars will actually have a starting system that will be lithium ion. I think the McLaren does SLA, I think that's the one. But the McLaren has a small pack there. All it does is start the vehicle. After that, it's switched to a different system. So the other one, you also have a special circuitry in there to balance the charge between the cells. So that keeps things looking a little differently. Now, we're going to go over and do a next thing on some battery charging rates. Okay, when we're doing battery charging, we have to make sure we look at the battery charging rate for the charger itself. So a sealed lead acid battery can charge between 14.8 and as 15.8. That's what everybody says. I've seen some of the chargers put 16 volts to these particular batteries. A sealed lead acid battery can handle that, so that's not a big problem. An AGM, absorbent glass mat, cannot. So a lot of them, they'll tell you the rate of the charge. You want to make sure it's 14.2 to 14.9. Now the battery I just showed you before said 14.4. So you want to make sure that you're setting the proper voltage charge rate for the battery, or else you're going to cause damage. Again, make sure you check the battery when you're charging it for heat and see if it builds up. A lithium ion battery, which I just talked about, they have to have a special deal up there. So they have to be charged somewhere between 13.6 and 14.4 volts. Your enhanced flooded battery is 14.2 to 14.4, so basically you can put one of those in a conventional car. It shouldn't be a really big problem up there because it would change a little bit. The gel cell for performance non-automotive applications, 13.9 to 14.1. Again, make sure you understand there are different batteries and you've got to start looking at this. As part of my research for this particular class, I have my eyes open to a lot of things that I didn't quite remember over a period of time. So it's something to keep in mind in looking at it. Now, when you're doing a battery charge, especially any charge except maybe some of the older ones that you bought, 2 and 10 amp, they're doing time rate. So if we're looking at this one, I want to make sure, this is from a friend of mine, an associate, I got the formula from them. Charging time, amp hour rated by the charging amp rate. So if I had this one, I have a 70 amp hour battery and I have my charger set for 10 amps. It will take me 7 hours to recharge this battery, all right? If I go over and if I figure out a rough charge time, I want to get really crazy. I thought this was real interesting because I had questions from 2 battery manufacturers, 2 charging companies, and I asked this question. I couldn't really come up with something, so here's the deal. Co-cranking amps divided by 8.3 will give you the amp hour rating. Remember, we used amp hour rating before. If I look at a 600 co-cranking amp battery divided by 8.3, I get 72 amp hours. That's why we're staying with 72 amp hours or real close to it. If the battery is at 11.9 volts, that's considered 85% discharge. They say discharge, I would tell you that I'd go the other way, but it's there. So we got an 85% discharge. If you wanted to go through all this math to do this, you would take 600 co-cranking amps divided by 8.3 times 0.85, because that is the discharge rate of the battery, divided by 40 amps, because that's what you're going to set your amperage to, times 1.5. So it's going to tell me I'm going to need to charge this battery at 40 amps. It's going to take me 1.9 amps to recharge. A lot of us don't want to go through all that math. I don't remember being taught that when I was in school. Of course, we used rocks to start cars when I was first in school, so it's a little different. But the reason I'm bringing this up is you don't want to overcharge the battery. So instead of having to do all this, a lot of the newer battery charging system analyzers will actually give you the charge rate in time. I just did a car over the weekend, and it told me if I had 10 amps, it would take me 247 minutes to charge. Well, I kicked my amperage up and I saw the chart. So there's something to look at. And some of those will tell you that it's there. If you're charging a battery, something a lot of us don't realize is there's a lot of science going to this. There are 3 phases. You have the bulk phase. It raises the battery up to 75% in a few hours because it doesn't have to raise the voltage that much. It basically is what it's saying, to fill it with amps. The charger takes this process slow to prevent the battery from getting too hot. So if you have a proper charger, it should not overheat the battery. And that's something a lot of us don't realize that. Okay, by the way, a 75% battery will not reliably start your vehicle for long, so they wanted to make sure you're looking at up to 75%. The next one, absorption phase. They're going to raise the voltage to push the last 25% into the battery. Charges up, returns to normal 12 volts. So we're going to increase the voltage to charge the battery. Once the battery gets up to return to normal 12 volts, and we're going to back it down again. So the process is the charger needs more voltage to finish putting the power in the battery. Higher voltage heats up the battery so the charger goes slow. If you have a defective charger, you might have problems with the battery getting too hot. So you want to make sure of that. What I tell people, I'm starting to tell people more as I did some things on this, is to always go out and check the battery. You got a temp gun, you got a hand. If that battery gets extremely hot, quit charging the battery and start over a little bit. The other thing is, if you get to the float phase on it, it will get the battery up to the level it's supposed to be. You now can take it off the charger. Your battery's up to 100%, so the charger turns to a trickle charger to keep the battery from slowly discharging while it's sitting there, which is something really interesting. So if you're not going back to that battery a period of time, it's a trickle charger to keep the battery at the maximum level, because batteries do just charge at time. Now, before we go any farther on the looking at it, there's something else we need to look at, is battery voltage. Medtronic has a little chart up there. They're telling you that you can go out and on the different batteries coming out of the process. So this was somewhere you can get on the BEV, battery electric voltage. They do have a 12-volt battery. It's usually charged to 14 volts because they have a DC to DC converter. This is where you're looking at the systems. This is some more information for you to find. And then we're going to start talking about on-battery vehicle sensors. On-vehicle battery sensors, it gives you the terminal voltage, the charging current, it gives you discharge current and the battery temperature. How do they do the battery temperature? They have a temperature sensor right on the lead going in there. Usually normally are connected to the negative post. So we're looking at the battery up there. And if I'm doing this one, there's a lot of information for you to look at. So we're going to look at stuff up there. So what I wanted to make sure everybody looks at, the battery sensor system, it checks the charge on it, and it gives you a stated charge in the system. It gives you the prediction on the state of what? Voltage up there, and it gives you the battery aging, state of health. So over a period of time, what they're going to do is check the battery with these sensors, and they're going to determine the state of health of the battery. And what they will do is increase the charge rate to compensate for that. So this is constantly going back and forth. The reason we're going to tell you when you're charging the battery, make sure you disconnect the negative cable, because you don't want to have the negative cable on when you're having the sensor hooked up. So what the computer is going to be doing this out and looking at it. The body control module might be doing this. There might be a separate module for doing charging on this particular vehicle, and the information is going to go back out on your network. So we look at some information. Now if I go over to this one, and we're looking at SOX, battery status signals. It's going to take all three. That's on your left-hand side. SOX says battery status signals. It's going to take SOC, SOF, and SOH, and it's going to look at that information. If we go to the middle of this one, the battery state detection is BSD. That's what that sensor is there for. If it looks at a charge prediction, and it says adaptable prediction of a deliverable energy and charge. So they are physically checking this battery on the vehicle for you, so they know that it's there. You're going to see a lot of these on start-stop vehicles that will have their particular system. If you go to the state voltage prediction, SOF, is adaptable prediction of voltage drops. On some of these particular vehicles, they are going to not charge the battery while it's going down the road. New GMs do that. A lot of times you'll see the battery voltage at almost nothing. If the battery's fully charged, they really are not going to keep the alternator going on. A little bit better fuel economy. If you look at the one down below, it says battery features, state of charge, state of function, state of health. So what it's basically going to be looking at is voltage of the battery for the charging system to make sure. It's going to double check to see it's proper, and they can actually vary the charging rate. It's looking at the current on the system so they can measure the current up there and the battery temperature. Most of us don't even think about battery temperature, but they have a sensor out there that's going to measure the battery temperature. If the battery is getting too hot, they are going to back off. If it's getting too cold, or I don't know why a battery gets too cold, but they do, you would actually increase it. So you're looking at the information that you were looking at. The battery system is doing that. The other thing is, once you replace the battery on these particular vehicles, because this system is constantly going in a closed loop, constantly charging, checking the ability of the battery to do its job, then what they do is when you exchange the battery or put a new battery in it, you must go to your scan tool and go ahead. There are specially made scan tools just for that. I have one at home where you do it. So you have to go out on your battery and do the awareness of the battery. You have to tell it that you have replaced the battery. Or else it will remember the charge rate from that battery's been in there 2 to 3 years, and that's a higher amperage rate than you would use for a new battery to keep the battery going across for a long life. So what it does is you have to tell it you put a new battery in it in order to change the charge rate back to what it should be with a new battery instead of what it was with a battery that has aged over a period of time. And there are some other external power sources you need to look at on your OnStar. And on some of these vehicles, we have 2 batteries, one for the start and stop and one for the main system. So you have to start looking at, you're going to have dual batteries on a lot of these vehicles. And the dual battery for the start and stop system is going to be smaller, lighter, and it's going to be remotely mounted. Also keep this in mind while I'm here. A lot of the batteries that are mounted in the trunk, like a BMW, might have accessory terminals that you're going to be using underneath the hood to check state of charge in the battery. Those are not going to be accurate because you have that long cable going to cause resistance. So in those, a lot of times what you will use is the old VAT40 or the carbon pile tester and load the battery down from there. And the battery manufacturers and the charging companies I've been talking to says, yes, that is still why they're there. That's still why it's a viable using tool. And they're seeing a lot of people starting to buy those tools again with the remotely mounted batteries. We're going to do some battery charging procedure. I want to make sure that you keep this in mind. Sooner or later, you need to read the specific instructions for your charger because there's going to be a little bit different than we've had chargers before. When you power up the charger, you either power it up now or you power it up a little later, but power up your charger, connect a battery backup to the OBD2 or the DLC connector, keep the computer's memory there so you don't have to change the radio stations later on and everything else. You want to do this much. You want to disconnect the negative battery terminal. The main reason you want to do this is you're going to wrap it up, prevent it from touching anything else. The other reason you're going to do that is you do not want to put excessive voltage while you're charging up the battery going back into the computer system. If I go to 15 volts, I really don't want to see that going into the system across. I know the battery absorbs some of it, but it's better if you don't. So we're looking at that particular setup. The next thing we want to do is do this. We're going to set the charger up for the type of battery you're testing, all right? You want to start the charger and wait. Depending on your battery charger, it may take up to 4 to 8 hours or longer for it to charge the battery. Keep this again. If I'm using an AGM battery, I want to set this charger up for an AGM. If I'm using an enhancer there, some of the batteries chargers will allow you to set the voltage itself at the level and make sure it doesn't go across a certain level. That's a great idea because you keep from damaging your AGM batteries. You're going to let this thing run. If you're doing a manual, you're going to do the process we talked about before. You're going to calculate and figure out how long it takes. Then when automatic charger will charge the battery, and then when they're done, they will tell you that they're done, and they will give you the voltage at the battery itself. Mine at home says 12.6 when it's done. It has a light that says I'm finished. So it's kind of neat. Then when you do that, you shut off your charger before disconnecting it from the battery, all right? So you want to make sure you turn it off. A lot of times I unplug it just to make sure, so you don't have an arcing and you're going across. You reconnect your negative terminal to the battery, you disconnect your backup battery and everything to your DCL, and you should be done with the process. Now, when you're charging this, if this was a new battery and you wanted to charge it up, again, make sure you don't have to reinitialize or relearn that you put a new battery in it. So that's a battery charging procedure. Big thing is, I've seen a lot of this over a period of time, never disconnect the negative battery cable. It is a good idea to be safe, to make sure. Proper charging, be honest with you, according to the manufacturers and the Battery Council tell you that you really should remove the battery from the vehicle. Sometimes that's almost impossible in these cars. So at that point, you're going to remove the negative battery cable to make sure you don't have a problem. Make sure that is away from the battery, tape it up, put plastic around it, do something to keep it from arcing anywhere, from arcing across to the chassis or from anything else going on the particular setup or the charger itself causing a problem. That's how you particularly do that. It's a good idea to teach your students do it, and the techs have to maybe relearn a new procedure for checking these batteries. I want to thank you for watching. You need to go out and practice this and get the use of the information we gave you. You can go out and also check us on your social media. We're a lot of different places, Facebook and a couple others. You will have other programs on this YouTube channel that you can look at and learn from. And I want to thank you for watching again. Make use of the information, and we'll see you later.